In this video, we're going to look at another way to solve system of equations. But first, in our do now, let's remind ourselves how to use that substitution method. So notice we already have y by itself in two places. So I'm going to take what y is equal to and plug it in. So we're going to rewrite this as x squared. Subtract 2x plus 3. And that all went in for this y. So I still have plus 2x. And it's equal to 1. And I'm going to solve that. But so I'm going to combine like terms. Notice the negative 2x and the positive 2x will cancel. We'll have x squared plus 3 equal to 1. And to move this over, we can subtract 3 from both sides. So x squared equals a negative 2. And to get rid of a square root, or to get rid of a square, we take the square root. And remember to put a plus or minus to both sides. Now in this case, when I simplify this, I'm going to have plus or minus I radical 2. So I get an imaginary solution as our answer, which obviously does not look so nice, and it's not like anything we dealt with before, but it's really not too overwhelming if we just take our time. I'm going to pull back that y plus 2x equal to 1 to solve this. So remember y, let's say plus 2 times I radical 2 is equal to 1. When I multiply that through, y is equal to 1 minus 2i radical 2 for our first pair. So that being said, when we had x was equal to I radical 2, 1 minus 2i radical 2 is y. Now we just have to do that one more time with the other pair. So we're going to have this time y plus a negative I radical 2. Oops. Let's fix that. So remember, we're going to have the 2 in front still. Negative I radical 2 equal to 1. So remember, I'd multiply that to get a negative 2i radical 2, but I'm going to add it to the other side. So we're going to have 1 plus 2i radical 2. So that coordinate would be negative I radical 2, and then 1 plus 2i radical 2. So just in case they ever give you something like intense like that, we still can solve it even with the imaginary. We just plug it in and solve as we go. But let's look at an alternative way of solving our systems today. So yesterday we solved systems using the two equations, using the substitution method. We're going to use the elimination method now. So elimination, just like it sounds, we want to cancel something out. So we want the coefficients, which are the numbers in front of x or y, to be the same number with opposite signs. And to make that happen, we're going to use multiplication. And so what I mean by that is if I look at this example number 2, we already have that the x's have that same number in front. But unfortunately, they're not exactly the same. So what I want to do is multiply the whole entire piece. Now I can multiply the top or the bottom by a negative. That way I have negative 6x minus 4y equal to, now remember, negative times a negative makes a positive 6. And I'm going to keep that first one exactly the same, 6x minus 8y equals 30. Now the only thing left for us to do is we can just combine these terms. So by combine, I mean we're going to add them. If I add them, the x's are going to get canceled. We're going to get negative 12y equals 36. And now it's pretty easy for us to solve from one of my pieces, my variables. When I divide negative 12, y is equal to negative 3. And same way we talked about yesterday, once you find one of those pieces, we've got to think that we got to plug it back in. So plug back into any of our originals. So 6x, we don't know yet, minus 8, we found y. And we're just going to solve. So 6x plus 24 is equal to 30. I'm going to subtract 24 from both sides to get 6, and x is equal to 1. So when we write this as a point, 1, -3. Okay, so same idea. We'll try on the next one. Now notice neither of our x's or our y's match. So we're going to multiply by something so that we can cancel out. And you can choose either number, either letter. So in this case, let's say I wanted to cancel out the y's. Now, 2 and 3 don't cancel out nicely. So I'm going to multiply 1 by a +3. And the second equation by a -2. Notice I'm using the opposite numbers, so that way we end up with something that's going to cancel. So if I look at that first one, we're talking 9x minus 6y is equal to 3. And -16x plus 6y is equal to +18. Now, by choosing those two numbers that were opposite of those y's, now the y's should be able to cancel when I combine these terms. So 9x minus 16x, or plus a -16x, we get -7. The y's cancel, equal to 21. When I divide both sides by a -7, x is equal to -3. And now to last step is just to plug into either of our equations. It does not matter which one you pick. 3 times -3 minus 2y equals 1. When I solve here, I'm going to add the 9 to both sides. And y is equal to -5. So that coordinate is -3, -5. So that is the solution of both of those two equations. Oops. Okay. Even if the x's and y's are in different orders, it's still totally fine. In this case, we can multiply either one to cancel. So I might multiply our first piece up here by a -2. That way we end up with -6y plus 4x equals -30. 6y minus 4x equals -12, stayed the same. And we combine, but look what happens. Not only do the y's cancel, but the x's cancel either, so I have nothing on this side. And it's equal to -42, but can that possibly be true? No, that can't happen, right? We can't have 0 equal to 42, -42. So this means there's no solution. Okay. One last one to consider. In this case, I'm going to multiply by, let's say, a -2. So we get -4y plus 2x equals -12. And we get 4y minus 2x equal to 12. Now, it's a little bit weird because when I add everything, I have 0 equals to 0. So that is true. This means there's infinitely many solutions, basically anything. It's not one set. So there are infinitely many solutions. So all real solutions. Because we're talking real numbers here. Because I want you to think about how the last two make sense. Think about geometry for a second. If you had no solution, and if we think about what we did with substitution, we know that two lines need to intersect. So if I go back here, these two different lines are formed and they have an intersection point. So this is one scenario that can happen. Or if lines never intersect, they could be known as parallel. And finally, when you rewrite these two lines, what's going to happen here is they're exactly the same. So if I have one line here, and if I have 0 equals 0, that means that this line is the same. So it's on top of each other, so every point on that line would be an answer. Okay? So those are the 3 different things that could happen when we're solving our